Hello, everyone. This lecture 3 on chapter 1, is the objective is to identify the number of terms in an algebraic expression, identify the numerical coefficient of each term, then simplify the algebraic expression. Okay, so we did look at algebraic expression in lecture 2. This is an algebraic expression. This is an algebraic expression. This is an algebraic expression. We did look at a couple of examples. Okay, let's define it. What is an algebraic expression? It is made up of one or more algebraic terms. So here I have listed two examples of algebraic expression. Okay. Here's the first one, and here's the second one. It is made up of one or more algebraic terms. What is a term? A term is separated by plus or minus sign. So this is one term. This is a second term, and this is a third term. Now, everything that we are talking about for the last couple of lectures is preparing ourselves or laying the foundation for the class in terms of getting ready for algebra. Okay. A term is separated by plus or minus sign. So between these two terms, there is a plus sign. Between these two terms, there's a minus sign. A term can be a constant, like we talked about in lecture 2. This is a constant which just has a number, or it could be just a variable, or it could be just a variable. So if I'm looking at this is one term, this is a second term. Just a variable. It could be a product of variables, or a product of constant and variables, product of constant and variables. So knowing how many terms are there, identifying the terms, identifying whether it is just a constant or whether it has a number and a variable is important. Now, the coefficient of the term is the numerical factor of the term. So if you're looking at problem example 1, this -2 is the numerical coefficient. So -2 is a coefficient of the first term. +4 is the coefficient of the second term. And what's the coefficient of the third term? Even though there is no variable, we can think of it being some variable, whatever it is, x, y, z, a to z, any number, any variable, and it has an exponent of 0, which is 1. So this x to the 0 means 1. So even though this has no variable, that -21 is a coefficient. So the coefficients of the first example is -2, 4, and -21. Key thing to remember is if there is a term, every term has a coefficient, and the coefficient is the numerical factor. The sign in front of the term goes with the numerical factor. Okay, so here if I'm looking at the second example, the z is by itself. Does that mean it doesn't have a coefficient? Not true. It does have a coefficient, and the coefficient is 1. The coefficient of the second term is -1/4. So two things. What is an algebraic expression? Could be a number, which is called a constant, or it could be a number multiplied by one variable or multiplied by several variables. Okay. How do these algebraic expressions are made up of terms, and each term is separated by plus or minus sign. And each term has a number, and that number is known as the coefficient. So this algebraic expression has 3 terms, and the coefficients are -2, 4, and -21. Here the z is by itself, but the coefficient is 1. Here the coefficient is -1/4. So why are we talking about terms? If you have an algebraic expression and it has like terms, then they have the same variables and the variables have the same power. Then what happens is terms can be added and subtracted if they are like terms. So the reason we are looking for like terms is just like if 2 numbers are together, we always add the numbers. Similarly, if you have like terms, when we are simplifying, we'll combine the like terms. Sometimes it is necessary to clear the parentheses before adding and subtracting like terms. So in this case, we're looking at example 1. It says simplify by clearing and combining like terms. So in this section, or in chapter 1, you are told to combine like terms. When we actually move into algebra and you're solving the equation for a variable, then you are expected to combine like terms and simplify it. You won't be told, all you'll be told is solve. So as you go along, whatever you've learned, you take it to the next section and the next chapter and so on. So if I'm looking at the first example, I'm supposed to distribute. So I'm using the distributive property, and this is a positive 1/4, which needs to be distributed here. Okay. So right now, if I'm asking you how many terms are there, these all are multiplied, right? And these are multiplied because if you have a number in front of it, it's assumed, or it is understood, not assumed, it is understood that it is multiplication. So then there is just 2 terms. Let me go to the next step after I distribute. Now, because this is multiplication and this is multiplication, there are just 2 terms. Okay, so when I distribute, I'm distributing the 1/4 to the 4k. So it is 4k multiplied by 1/4, the 4 goes in the denominator. So I'm multiplying the numerator. This 4k has a denominator of 1. So I multiply the numerator 1 times 4k, which gives me 4k, and 4 times 1 just gives me 4. Again, I distribute the 1/4 to the 2. What do I get? Plus 1 multiplied by 2 just gives me 2, and the 2 has a denominator of 1. 4 times 1 is just 4. I know some of you are saying, can we simplify? Yes, we can simplify. Next, again, I'm distributing this -1/2 to the 6k. The 6k has a denominator of 1. So I multiply -1 times 6k, -6k, and 2 times 1 just gives me 2. This whole fraction is negative. Then the -1/2 is distributed to the 1. 1 times 1 is 1, and 2 times 1 is just 2. So before I distributed, when I asked, I said because they are multiplied, they're just 2 terms. But after I distributed, there is 1, 2, 3, and 4 terms. Okay. Now I will combine. What are like terms? They have the same variable, and the variable has the same power. So this has a k and this has a k. This is k to the 1 power, k to the 1 power. So they both are alike. So I can combine them. Before I combine, I will simplify this. 4 times is divisible. I'm just left with k. 6 divided by 2, and it gives me 3k. 2 divided, this 2/4 is, this is divisible by 2, this is divisible by 2, it gives me 1/2 and -1/2. So what I did is I brought like terms together. This is a like term and this is a like term. Okay. This is a like term and this is a like term. Okay. Now, when I combine, this k has 1. This is a like term. The coefficient is 1. The coefficient is -3. So when you are combining like terms, that is adding and subtracting, the variable stays the same. So the k stays as it is. You're just adding and subtracting the numbers. So 1 minus 3, so that gives me -2k. Positive 1/2, -1/2. When you add, like denominators 1 minus 1, 0/2, and the answer is, so this is when you are combining this, it is positive 1/2 minus 1/2, 0/2, which is 0. So the final answer is just -2k. Good. So we started off with 2 terms because they are multiplied. And when I distributed, I ended up with 4 terms. Then I'm simplifying by combining like terms. Like terms have the same variable and the variable has the same power. So if this is to the 1 power, this is to the 1 power, that's why it's same. If you have a k squared and 3k squared, then these are like terms because they are the same variable and it's the same power. Good? Good. Okay. Again, if I'm looking at this right now, before I do the distribution, this is 1 term, this is a second term, and this is a third term. Okay. I cannot combine like terms unless I do use the distributive. So I'm distributing the -3 to the first term here and the -3 over here. So when I do that, -3 times 4, -12s. And a negative is multiplied by negative ends up being positive. So 3 times 6 is 18, and the variable is t. Next, let's look at the next one. -4 is distributed to 3t, so I get -12t. -4 is distributed to 5s, and I get -20s. And the last term is -2s. Again, when I started, because they were first 2 were multiplied, there was just 1, 2, and 3 terms. After I distributed, I ended up with 1, 2, 3, 4, and 5 terms. So each of these are 1 term. Now, my next step is to combine like terms. So when I'm combining like terms, I see this is a like term, and this is a like term, and this is a like term. So I will bring the like terms together. When I bring the like terms together, I make sure I bring the sign in front of it along with it. So -12s -20s -2s. So they all have the same variable. Okay, that's why they are like terms. I will bring 18t, positive 18t, and -12t together, because they are like terms. They have the same variable and to the 1 power. Now to combine, all I need to look at is just the coefficient. All I'm looking at is just the coefficient. So it will be s, but -12 -20 -2. They all are subtractions. So let me go from left to right. -12 plus -20, it'll be -32s -2s. Plus 18t minus 12t, it'll be a t. So when the signs are different, you're subtracting, and this is positive, the sign will be, final answer will be positive. So minus 2 is 6 and 1. So it will be positive 6t. So remember, when you're adding and subtracting, the variable stays the same. You're just focusing on the coefficient. Next, I'm not done simplifying the s. So negative 32, negative 2, negative 34s plus 6t. And that's my final answer. Again, look at the number of terms, 1, 2, 3. After I simplified it, became 1, 2, 3, 4, 5. I look at the variable, see if they have the same power and the same variable, then they are like terms, and I combine. So the s's were like terms, I combined, they were all negative. So you add and keep the common sign. Here, this is positive, it's negative. So you subtract and use the sign of the number with the highest absolute value. Sign of the number with the highest absolute value. I hope this makes sense. Please watch. As you're watching, do the problems, take notes, come to class with questions, okay? Now, each of these, the variables were to 1 power, okay? So they were, when it is to the 1 power, they are known as linear expressions, linear algebraic expression. Now, what we will look at, combining like terms in a quadratic expression. The rules does not change. The process does not change. The process stays the same. That is, you combine the variables with the same power. Combine terms that have variable to the same power. So in this case, I did not have to do distributive property, but let's count the number of terms. 1, 2, 3, 4, and 5. How did I say these are 5 terms? Because they are separated by plus or minus. Now, in this case, I know the coefficient of the first term is negative 10. The coefficient of the second term is positive 7. Coefficient of the third term is negative 18. Coefficient of the fourth term is negative 5. Coefficient of the last term or the fifth term is negative 7. So these are all coefficients. Okay. 1, 2, 3, 4, 5 terms. Terms are separated by plus and. What is a coefficient? The numerical factor in the term that is multiplied to the variable or is by itself. Okay. Now to combine, I know this is quadratic. What does it mean? Quadratic implies there is a variable or term with variable of degree 2. Okay, so whenever you have in an algebraic expression, the highest power in the variable is 2, then that expression is called as a quadratic expression. Now, if you look at an equation, if you have an equation where the degree of the variable is 2, then it is called as a quadratic equation. So whenever you have degree 2, the highest power of the variable in the expression is 2, then it is called as a quadratic expression. If I looked at the earlier expression, the power, it was 1 in this, and this, there are 2 variables, but the highest power is 1. S to the 1 power, T to the 1 power, just like we don't write a number with a denominator of 1. When the degree or the power of the variable is to the 1 power, we don't write it. So therefore, because it is to the 1 power, we call it the linear expression. is to the second power, you call it as a quadratic expression. Now I'll combine like terms. Like terms are terms with the same variable and same power. So this is negative 10 and negative 18x squared. I bring those two together. Negative 10x squared, negative 18x squared. Next, this is a like term and this is a like term. So I'll bring that together. Positive 7x, negative 5x. And the last one is just negative 7. The constant of the fifth term is negative 7. Okay. So to combine, when I add these two, I will still get the same. The variable and the exponent stays the same when you're adding and subtracting. Once again, when you combine like terms, you keep the variable and the exponent. All you focus on is the coefficient changes. So negative 10, negative 18, you're moving left to on the negative side. You first move negative 10 steps, then move negative 18 steps, or you are, when the signs are same, you keep the common sign and just add the two numbers. So you get 8, 1, 1, 2. So it is negative 28x squared. Keep this in mind. This idea of combining like terms gets repeated again in chapter 4 or 5. So you can't forget it. When you're adding and subtracting like terms, even when it is a quadratic, you will see combining like terms in the next chapter. But combining like terms, quadratic expressions will again be repeated sometime later on down the road in chapter 4 or 5. So don't forget it. So it becomes negative 28x squared. Now I'll combine positive 7x and negative 5x. So again, the variable stays the same. The power is 1. It stays the same. I don't need to write it. But positive 7, negative 5, it's positive 7 to the right on the number line, and then you move 5 steps to the left because it's negative 5. Since 7 is bigger in absolute value, the sign is going to be positive. 7 minus 5 is 2. Now there is no other constant, so you just bring the like term. So we started off with 5 terms. Combining the like terms, we ended up with 3 terms. Negative 28 is the coefficient of the quadratic first term. 2 is the coefficient of the second, and negative 7 is the coefficient of the third. So it's a short lecture, lecture 3. All we are talking about using the distributive property and combining like terms so that our final expression is simplified. That's all I have for this lecture. Please take notes as you are watching. Come to class with questions. Thanks for watching.